Good morning, ladies and gentlemen. Welcome back to Algebra class. Today we're going to be talking about dividing monomials. To simplify an expression involving monomials, we write an equivalent expression in which each base appears exactly once, there are no powers of powers, and all fractions are in simplest form. You'll want to pause this video and write those down. So next up we have some dividing monomial properties, and once again this is one of those things I will open all these up for you and you are free to write them down. Basically, if we have a quotient of powers, we are going to be subtracting the two exponents. If we have a power of a quotient, we're going to distribute that power to each individual thing. If we have a zero exponent, anything raised to a zero power is going to be 1. If we have a negative exponent, basically that tells us to flip our fraction. Once again, you'll want to pause the video and get that all copied down. Let's go ahead and look at a couple examples here. So our first example is x to the 8th power over x squared. And basically what that is telling us to do is we have x to the 8th over x squared. So each of these has two x's that can be canceled out. So when I do that, 8 minus 2 leaves me with x to the 6th up top over 1, which can be simplified to just x to the 6th. Next up, we have 5p over 10p to the 6th, and I like to break this down into two little separate problems. So I have 5 over 10 times p over p to the 6th. And then I just break this down. 5 divided by 10 is going to be 1/2. P over p to the 6th, I have a 6, and then that other p actually has a 1 with it. So 6 minus 1 is going to be 5. My bigger number is on the bottom of my fraction, so I have to rewrite it as 1 over 6 minus 1 is p to the 5th. Now I simply just multiply my top part and my bottom part. So 1 times 1 is going to be 1 up top. 2 times p to the 5th is going to be 2 p to the 5th. And there's my final answer. Okay, let's look at our next problem. So here we have to distribute that 4 to each thing. And remember, that's a power to a power. So b to the first power to the 4th power is going to be b to the 4th, because we multiply those together. And then b to the 4th to the 3rd power is going to be 4 times 3 is 12, so it's going to be b to the 12th power. Now I simplify just like I have before. So 12 minus 4 is 8. My bigger number is on the bottom, so it's going to have to stay on the bottom. So it's b to the 8th. Now this one looks difficult, but it's really not too bad. We have this whole thing is being raised to the 0 power. So what that really tells us is our answer is going to be 1, because anything raised to the 0 power is simply 1. Okay, let's look at our next problem here. So once again, we have this whole thing being raised to the 0 power, which is just going to give us 1. Then we have plus 3. So 1 plus 3 gives us a final answer of 4. Here we're just going to simply rewrite this. So b to the 1/2 power. Anything raised to the 1/2 power is like taking the square root. So b to the 1/2 power is the square root of b. Z to the 1/3 power. Anything raised to a 1/3 power, that's like taking the cube root. So we can rewrite it as the cube root of z. On our last problem, we talked about how anything raised to a 1/2 power is really like taking the square root, and it goes the same in the opposite direction. So the square root of m can be rewritten as m to the 1/2 power. Here we have the cube root of n, which can be rewritten as n to the 1/3 power. Here we have b to the -4, so that's really over 1. Whenever we have a negative exponent, if it is on the top of the fraction, we flip it to the bottom and make it positive, and if it's on the bottom of the fraction, we flip it to the top and make it positive. So in this case, we have b to the -4 is up top, so we put it on the bottom. So we go 1 over b to the 4th. Now, because it's positive, we are all done. Here we have 10 to the -5, so that's going to be the same type of situation. We have a negative, we're not allowed to have that, so we need to flip the whole thing, and we have it as 1 over 10 to the 5th. On our next problem, we have each thing raised to the -7th power. So we have 3 to the -7 over 8 to the -7. The 3 to the -7th is up top, so we're going to flip that to the bottom. The 8 to the -7th is on the bottom, so we're going to flip that to the top. So we can simply rewrite this thing as 8 to the 7th over 3 to the 7th. Same type of thing as last problem on this one, so we can rewrite this as x to the -4 over y to the -4. And then x to the -4 needs to flip to the bottom, y to the -4 needs to flip to the top. So we're going to have y to the +4 up top, x to the +4 on the bottom. Here we have -3 is going to be raised to the -3 power. We have b is going to be raised to the -3 power. This whole thing is over 1. So once again, because we have our negative exponents, it needs to flip to the bottom. So we have 1 over 3 to the 3rd, b to the 3rd. Here, same type of thing. We have 3 to the -2. We have m. 2 times -2 is going to be -4. And we have n to the -2. That is over 1. So we flip everything to the bottom because they're all negative powers. So we have 3 squared. We have m to the 4th, n squared. This is our last example here. It says find the length of the rectangle with the given area. So remember, area equals base times height. So what I would do for this is I know that my height is 4a to the 4th times b. I need to figure out my base. And I know that these two things have to multiply together to be 36a to the 4th, b to the 4th. So what I would do is I would ask myself, what multiplies by 4 to be 36? And in this case, it's 9. And then I have a to the 4th. I don't have to multiply by anything to get my a to the 4th there. I do have a b to the 1st right here. So I need to have 3 more b's to be able to get to b to the 4th, so it's going to be b to the 3rd. So my final answer is that side length has to be 9b to the 3rd power. That's the end of our lesson here today. Have a great rest of your day.